everyone. So the good news today is I have a good econ class for you. You may say, what is a good econ class? Good class is one where it's semi-interesting and it's not super difficult. So that's what I have for you today. What we've been talking about the last few weeks is what a demand curve is and how we get one, what a supply curve is, how we get one, what changes the location of a supply or demand curve. And we know that for both the supply and demand, we get given quantities at different prices. So an overarching question is, well, in a market, what determines which price you're actually sitting at? So that's what we're going to talk about today. So we're still in chapter 4. This is, I believe, part 4. We've got one more part and then we'll be done and take an exam. And the important word for today is going to be equilibrium. So first of all, what is an equilibrium? Okay, just very descriptively, if you think about the definition of an equilibrium is basically kind of a scenario where everything's just kind of in balance. There's no tendency for like ripples to keep happening. It's like the waves are just smooth. We're at a calm, steady state. And so what we're going to think about is where we would get an equilibrium in a market. So, very, again, descriptively, equilibriums occur when various forces are in balance. And in our context, this is going to be a situation where the market price has reached the level where the quantity supplied is exactly equal to the quantity demanded. Okay, let's just think about this in terms of the actual picture. So what we've been drawing is supply and demand curves where we always have price along the vertical axis, quantity along the horizontal axis. Since the plane that we're looking at is the same, like we always have price against quantity, we can just take the two curves we've been looking at and we can just overlay them in the same space. So we would have a downward sloping demand curve to reflect the fact that ceteris paribus, if you've got a good and it becomes cheaper, what happens? The quantity that people demand goes up. We've got a supply curve that is vertical, which reflects ceteris paribus. If the only thing that happens is that the price of something goes up, well, if I'm selling that good and suddenly I can get more money from selling it because the price point is increased, what happens? I ramp up my production and I supply more. Okay, think about what we've got here so far. So what we have here is something that says we will get an equilibrium in the market. We'll get the market to quit like churning if we get to a scenario where the quantity supplied equals the quantity demanded. And specifically, we get there when the market price reaches that level. Okay, the idea here is in markets, we've got a whole bunch of different prices that are possible. And the price is going to be this thing that determines where we're sitting at along the horizontal axis. So the idea is that there's going to be churn in the market, like the price is going to go up and down, until it kind of settles at a particular location. And that particular location is the location where the quantity supplied is exactly equal to the quantity demanded. Okay, think about this. For the demand curve, we've got a whole bunch of different coordinates. These coordinates tell us for a given price, this is the quantity people would demand. This is, for this price, the quantity people would demand. For the supply curve, we've got coordinates. This coordinate would tell us at this price, this is the quantity people would supply. At this price, this is the quantity people would supply. So the quantity can be thought of as the quantity demanded or quantity supplied. It's just like a numerical way to represent the number of units that are either being demanded or supplied. So where is quantity supplied equal to quantity demanded? It's equal at the intersection of these two curves. And that corresponds to a particular price. Okay, so what we have here is at the intersection of these two curves, what I have written is that we're going to get an equilibrium which means the price is going to quit kind of going up and down. It's just going to be happy to sit there perpetually. And when the price sits there, well, what's going to be happening on the demand side? Well, if I'm buying this good, and here's my schedule of number of units I would buy at different prices. If this is the price, then for the demanders, this is the quantity they would demand. If I'm at this price and I'm a supplier, well, if that's the price and I'm the supplier, then this is the number of units that I would supply. And so at the intersection of these two lines, we have a given price that corresponds to a location where the quantity demanded is equal to the quantity supplied. Okay, so this happens, all of this happens when the supply and demand curves intersect. Okay. Just to make sure this is abundantly clear, I'll draw this one more time since this graph is getting kind of scratchy with all my notes. Okay, when we have that situation, so we have the demand and the supply crossing each other, that's going to correspond to a particular price. This particular price is going to be labeled the equilibrium price in the market, and this is going to correspond to a particular quantity. This is going to be labeled the equilibrium quantity in the market. And because they're equilibriums, at this location, the market would be happy to just perpetually sit there and not keep on kind of jostling. So it could just kind of hang out and be happy to just kind of perpetually stay at a state where there's this many units being bought and sold at a price of this level. Okay, so that kind of begs the question, well, how do we get to that kind of scenario? So if the tendency of the market is for the price to kind of fluctuate until it hits this sweet spot, then what does that kind of fluctuation dynamic look like? Okay, this is where things are just kind of interesting. So I'm going to put on the board a really big and a really neat supply and demand chart that is going to be drawn to scale today. I'm really going to make efforts to draw to scale. So make sure for frustration minimization as you're studying that you also draw this to scale. Okay, so let's draw. We'll have a market for ice cream cones again since we've been thinking about ice cream cones for the last several weeks. Let's have a market for ice cream cones, and let's have the prices increase in 50-cent increments from 0 up to $3. So we'll have 0, we'll have 50 cents, we'll have $1.50, we'll have 0, we'll have 50 cents, we'll have $1, we'll have $1.50, $2, $2.50, and $3. And then let's have the quantities increase in 1 unit increments from 0 to 12. So we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, make it a little bit longer, and 12. And then we can label these. Okay, I'm going to try to make the numbers consistent with the numbers we used when we were calculating the market supply and demand. So if you go back weeks ago and we were thinking about the market demand curve, we had 2 people who were demanding ice cream cones, Al and Bob, I think. We horizontally summed their demands, we got the market demand. I'm going to keep those same numbers just for consistency. Same thing for supply. So on the supply side, we had Ben and Jerry making ice cream cones. We horizontally summed their supplies. We got market supplies. I'm going to keep the same numbers. Okay, so the numbers that we had, we'll start with the demand. So on the demand side, if the price was $3, then there were 3 units that were demanded in the market. So at 3, we're going to have a coordinate. If the price was $2.50, then there were 5 units demanded in the market. If the price was $2, there were 7 units demanded in the market. And so forth. So we just kind of keep on going over 1, over 2. Okay, so we can connect those dots, and we can get the market demand curve. Okay, on the supply side, if the price on the market was $1.50, then there were 4 units that were supplied. So there's a coordinate here. If the price was $2, there were 7 units that were supplied. If the price was $2.50, there were 9 units supplied. Okay, so we're going to keep connecting the dots and have a market supply. Make sure, keep going a little bit more. So this $3 corresponds to 11. This $2.50 again corresponds to 9. What else am I missing? Okay, I'll keep on adding numbers as I need to. Okay, so what we have now is just the demand that we derived, plotted, the supply that we derived, that we plotted. Okay, think about what would happen in the market if the price in the market started out at like $3. So again, we don't always start with an equilibrium price. The idea is that the price kind of oscillates, and it keeps on oscillating until it hits the crosshairs. Once it hits there, it quits moving, and we're in equilibrium. So to start with, we just have to like pick a price in the market. So let's suppose we start with a price of $3. Well, what would happen if the price was $3? Well, let's first of all think of what the demanders would demand. Well, if I'm a demander, then this curve tells me the number of units I would demand at different prices. So if the price is $3, then as a demander, how many units do I demand? $3. So this would be the quantity demanded at a price of 3. If the price is 3, let's think about what happened on the supply side. Well, the supply curve tells us the number of units that sellers would be willing to supply at different prices. So if the price is $3, well, sellers would be willing and able to sell 11, so this would be the quantity supplied. Okay, just think about what would kind of pan out in the market if this is the case. If this is the case, then all the units, all the ice cream cones would be exchanged at a price of $3. Well, it's kind of a high price, so not very many people want to buy ice cream cones at $3. In fact, there's only 3 people who want to buy an ice cream cone. But that's a high price, so sellers, they're happy to sell ice cream cones at $3. So sellers would be willing to sell 11. So this would kind of be like there's 11 ice cream cones sitting on the shelf that are being offered for sale. Only 3 of them are purchased. So what would happen is you would have some leftover ice cream cones on the shelf that aren't being sold because the supply exceeds the demand. So the horizontal distance here, which corresponds to the difference between the quantity demanded and the quantity supplied at this given price level, that horizontal distance will be the amount of surplus that there is on the market. And specifically, there's going to be a surplus of 8 units here. Because again, there's 11 ice cream cones sitting on the shelf, 3 of them get purchased, there's 8 numbers between 11 and 3, so there's going to be 8 left over, and that's going to be kind of leftover ice cream cones. Well, if you're a seller, it's bad news to have ice cream cones on the shelf that nobody's buying. So if you realize that people are kind of put off by your high price, and so you've got extra ice cream cones on the shelf, what's a reasonable response? A reasonable response is just, well, people think this is too pricey, let me lower my price. Okay, so what would kind of happen is this iterative process where you start at a price that's too high, We have this surplus of ice cream cones that are sitting there. Stage 2 of this game is that the suppliers will lower their price to get rid of some of their surplus. So maybe they decide, you know what, we're going to lower our price to $2.50. Okay, think about what would happen here. At a price of $2.50, what would the demanders, how many units would they demand? Well, at a price of $2.50, that corresponds to 5. So there would be 5 ice cream cones that people will be willing and able to buy. So again, intuition, this should make sense. The price is lower, now more people want to buy it. Okay, but what about the supply side? So suppliers, I mean, this isn't as great of a situation for them because now they're not selling their stuff at as high of a price. And so if the price is $2.50, well, we see from the supply curve that now only 9 ice cream cones are going to be offered for sale. Okay, so what do we have? We have 9 ice cream cones sitting on the shelf for sale. Only 5 of them are purchased. That means there's 4 left over that aren't sold. So now we're going to have a surplus still, but it's going to be smaller, and specifically, it's now going to be 4. So again, the horizontal distance between the supply and the demand at a given price level tells you the extent of the surplus. So we're just subtracting these 2 numbers, the quantity supplied from the quantity demanded. Okay, we're effectively going to have a similar round of actions. So the suppliers are going to be like, well, we sold a few more, but we still got some leftover ice cream cones sitting on the shelf because consumers are still put off by this high price. So let's just lower our price again. So maybe this time they lower it to $2. If they lower the price to $2, then at a price of $2, here's the demand curve. So people would be willing to purchase 7 ice cream cones. On the supply side, if the price is $2, then there are going to be 7 ice cream cones that sellers are willing to sell. And so we're at a situation now where the number of units that are sitting on the shelf is exactly equal to the number of units that are purchased. And so they don't have any extras. There's no more surplus. And so since there's no more surplus, they're not going to lower their price anymore because they want to make a high price. And this is kind of the minimum price they can sink to eliminate the surplus in their inventory. Okay, so the idea here is the price kind of oscillated, or specifically it started at too high of a level, and it just kind of kept sinking and sinking and sinking and sinking until it got to the equilibrium price. Once it got there, the sellers have no more incentive to kind of change the price point because they're getting rid of all their ice cream cones, and of course they don't want to sell it for less than that because then revenue sinks. If they sell it for less than that, then you're bringing in less per unit that you're selling. Okay, so in this case, we've demonstrated that if you start out with a price that's too high, 1, you have a surplus. The extent of the surplus is the difference between the quantity supplied and the quantity demanded. The second thing that happens with a surplus is the price sinks. You get to a new surplus, potentially. The new surplus is still the difference between the quantity supplied and quantity demanded. You got a surplus, they've got to lower their price again to get rid of some of their inventory. Once they get to the equilibrium price, they stop lowering their price, and so the market just we're not going to move the price anymore. This is where we're sitting forever. Okay, so that's surplus. What would have happened if instead of the price starting out at a level that's above the equilibrium, suppose the market just started from a situation where the price started out kind of lower than what it should be. So let's look specifically at a price of $1.50. Okay, so at $1.50, what's going on? So at $1.50, so that would be right here, between 1 and 2. Then let's start with the demanders. I didn't quite draw this all the way out yet. Price of $1.50. Actually, I did not draw this to scale to begin with. This is going to correspond with 10. Okay, at a price of $1.50, well, demanders, they think that's kind of a good price. And so the price is pretty low. So if the price was $150, we go over to the demand curve, we see where we intersect, and it's going to be at 10, if I actually did drop the scale. This is not going to be the quantity demanded. So there's a whole bunch of people who are eager and ready, willing and able to buy ice cream cones. But for the suppliers, a low price isn't great news because they're not making as much money per thing that they sell. So if the price is only $1.50, we see where $1.50 intersects the supply curve. Here it happens to be 4. And so this is going to be the number of units that are supplied. Okay, just like think about like descriptively what's going on. We have a kind of a cheap price. So there's a whole bunch of people lined up to buy ice cream cones in front of the ice cream shop, but there's not very many ice cream cones being offered. So there's going to be 4 ice cream cones on the shelf. This is the supply, but there's going to be 10 people lined up to get ice cream cones, and so that means we have a shortage. So now the horizontal distance between the supply and the demand, that is going to indicate the number of units that we're short in the market. So this is going to be the extent of the shortage. And specifically here, we're going to have a shortage of 6 units because 10 people want an ice cream cone. There's only 4 that are being offered, so we're short 6 units. Okay, why would the market change from this point? The market would change from this point because the sellers realize, like, I sold all my inventory. There's still people lined up outside wanting to buy an ice cream cone. Like, I could raise the price a little bit, and I could still, like, sell my ice cream cones. So if we started out here, then because of this shortage, sellers realize, like, people like my product, like, I'm just going to raise the price, and I can just kind of not have a surplus still. So if they raise their price, for example, to $2, then what would happen? Well, at a price of $2, there would be 7 people lined up to get an ice cream cone because $2 intersects the demand curve at 7. $2 intersects the supply curve at 7, so this is going to be the quantity supplied. And so what this means now descriptively is that once they've raised the price up to $7, well, we've got 7 ice cream cones sitting on the shelf. There's exactly going to be 7 people that line up to buy the ice cream cones. They've completely sold out of their inventory. They're not going to keep raising the price because if they raise the price up to $2.50, well, then what we previously talked about would happen. We would now have, like, a surplus because you would discourage customers with your high price. And so they're just going to, like, just be satisfied with $2. At $2, they exactly get rid of all their inventory. And if they raise their price any higher, then they're going to, like, discourage customers and have a surplus. Okay, so make sure this is clear for the exam. I'm going to draw you kind of a side-by-side comparison so you can make sure you get this. So this is going to be a side-by-side comparison of a surplus and a shortage. Okay, surpluses only occur when the market price is above the equilibrium level. So if we have this going on and the price is too high, maybe the price is up here, then at that high price level, the difference between the quantity supplied and the quantity demanded is going to be the amount of the surplus. So to calculate numerically the number of units that we have in excess, you would just figure out what is this quantity supplied, what is this quantity demanded. That's going to be a number and a number. You subtract them, and that's the number of units you have in surplus. Okay, shortages are only going to occur when the price in the market is lower than the equilibrium price. So if we've got this kind of setup going on, and the market has a price down here, well, this price, this is the number of units that are offered for sale. This is the supply, quantity supplied. This is the number of units that people want to buy. So you got people demanding this many units, suppliers supplying only this many units. So this is going to be the extent of the shortage. Okay, again, to numerically calculate this, you take this price, you peg it, you go over to the supply curve, you figure out the number for the quantity supplied, you go over to the demand curve, you figure out the number for the quantity demanded, you subtract them, and that gives you the shortage. Okay, again, what is possible is that a market may start out with a price that's too high. If that's the case, then the forces of the market are going to push the price down so that it gets to the equilibrium. Maybe the market starts out with a price that's too low. The forces of the market are going to push the price up so that we get to the equilibrium. So eventually, we always kind of have momentum that's shifting the price towards the equilibrium. Once we get to the equilibrium, then there's no incentive to alter the price further, because if you alter the price from this kind of sweet spot, either you're going to have leftover units that aren't sold, or you're going to have more people lined up to get the good than offered for sale. In that case, the sellers are kind of missing out on some sales that could be happening. And so all the forces are going to kind of gravitate towards the equilibrium. Once it gets there, it's just going to stay there. We're going to be in an equilibrium. Okay, so I'm going to put what I said in word format so it's in your notes, and then we'll be done for the day. So the law of supply and demand says basically what I described. So the price of any good adjusts to bring the quantity supplied and the quantity demanded into balance. So the price of any good adjusts to bring the quantity supplied and the quantity demanded into balance. Okay, so the last thing, I'm going to put a star next to this, is because we're kind of always gravitating towards equilibrium, if we have a surplus, it's going to be temporary, because the surplus is going to keep on kind of minimizing until it's gone. And similarly, if we have a shortage, it's going to be temporary, so the shortage is going to kind of minimize until it's gone, because we're always kind of heading towards equilibrium. So I'll put kind of as a caveat, in most markets, shortages and surpluses are temporary. So they don't last forever. So we always move away from them, which is why they're not in equilibrium. Okay, so that's all I've got for you today. Next class, we're going to have our last part of chapter 4, and it's really going to bring it all together. But make sure that you're definitely clear on surpluses and shortages and how to calculate them. Let me know if you have questions in the next 10 minutes, and then after that, we'll come back for the exercise. Okay, the task for today's exercise is consider the following market. This market. I've drawn everything very much to scale. I put up the grid lines during the break to make sure I was getting exactly right. So we have a supply curve that has one coordinate at 1, 100, another coordinate at 2, 200, 3, 300, so forth. We have a demand curve that has a coordinate at 6, 0, $5, 200 units, $4, 400 units, and so forth. Okay, what I would like you to do is I would like you to think about, for given prices, whether there would be a shortage in the market or a surplus in the market, and how much of a shortage or surplus. So question number 1 is, if the market price was $6, so if this is the market price, then would that result in a shortage or a surplus? And how much of a shortage or how much of a surplus? For question 2, shortage or surplus, and by how much for a price of $2? Do the same thing for a price of $5, and the same thing for a price of $3. This should be very simple. If this is not simple, you're in trouble. So make sure you're clear on this. Check your answers against the correct answers that I give you after you submit, just to verify things are clicking. And after that, you'll be done with econ for the day.